Alright, moving right along into surface areas of pyramids. We last encountered pyramids when we were in chapter 9, and hopefully you remember a little bit about them because we will use that same information here. So a regular pyramid is just a pyramid whose base is a regular polygon, and then the lateral faces are all going to be congruent isosceles triangles. So this right here is our typical pyramid that has a square base, right? But remember, it can be any regular polygon for the base. So in this case, this is a regular pentagon, okay? And where they say the lateral faces are congruent isosceles triangles. So these triangles that all kind of meet up here at the vertex, they're all going to be congruent to each other, and they're all isosceles. So that's all very good information to help us figure this out. And remember, we also had something called a slant height. So in a pyramid, if you go from the vertex down to, ooh, that was terrible, let's try that again, down to the midpoint of the side right there, and it's going to be perpendicular to that side. That is called the slant height. Okay, so when we go to figure out surface area, we have the lateral area and we have total area. So the lateral area, you could, just like I said before with the prisms, you could actually figure out the area of each of these isosceles triangles and then add them up together, or multiply by 4 because they're all going to be congruent. Or if you wanted a formula, we can take 1/2 the perimeter of the base and multiply by the slant height. And so this formula is very similar to that other formula we had for the lateral area of a prism, which was the perimeter of the base times the lateral edge, only this time we're taking 1/2 of the perimeter and we're multiplying by the slant height. Okay? If you don't remember this formula, you can always go back and do it, you know, the manual way, where you're just adding up the areas of all 4 of the isosceles triangles, or in this case there would be 5 isosceles triangles. And then you figure out, obviously, the total area is going to be the lateral area added to the base of the pyramid. Okay? So let's do an example. So this one tells us that the lateral edge is 10. So remember, that's this piece right here. This is 10. And that means this is also 10. And then the one in the back is 10. And this one is also 10. Okay, the base is a square with sides of 12. So all 4 of these lengths right here are going to be 12. So we need to find the lateral area and the total area. So the information that was given to us is that this is 10, this is 12. We're going to need to know the slant height. So we're going to go ahead and draw that in. And we know that the slant height goes to the midpoint of this side, so that's going to break up the 12 into 2 equal parts of 6. Remember that this is a right angle. I'll even draw that in for you to remind ourselves. Okay, so we do have a right triangle here, with this being 6 and that being 10. This is the hypotenuse, so hopefully you remember Pythagorean triple. So we know that that's 8. So that tells us that the slant height is going to be 8. So using our nifty formula, we have 1/2 the perimeter, which 12 times 4 is 48, and then multiplied by the slant height, which is 8. So this comes out to be 192 square units. Okay, and so if you remember that the total area of your pyramid, you're just going to take the lateral area, add on the area of the base, which is 144, and that gives us 336 square units. Piece of cake, right? All right, that will be it for us today.